Hi again. Today I have already solved it and I would like to explain it. It's from Shear Strength of Soil chapter. After conduction of all the tests, you'll have the idea what the questions is demanding. After only that, you will be able to solve the problem, because there are many parameters that you need to understand before solving the problem. I might sound too boring, but this is way I speak. Actually, I'm not boring. I'll try to make it as sweet as possible. A consolidated drain test was conducted on saturated clay, which have the following data. Cell pressure is given to 50 kN per meter square. Deviator stress is given to 175 kN per meter square. But we need to determine angle of internal friction, angle of failure plane with major principal plane, normal and shear stress on a failure plane, normal shear stress on the plane of the maximum shear. And these are not question actually. These are the things that I brought down after the completion of the question, so that while explaining it will be easy to make you understand or to make myself understand. It says that it is a drain test, and after that on saturated means you need to have the idea. It could be pi soil or it could be C-pi soil, and again there is a condition like as you can see that here it's only the sail pressure and the deviator stress is given. No other parameters are available. So from here you need to be able to identify that the test has been conducted, only triaxial test has been performed only one time. Okay, if there was more than two parameters, see I've written here two test result or one test, two test result or one test or more data was given, then we would have adopted the C-pi soil. But for this case it's only given two parameters, cell pressure and a deviator stress. One test has been performed, so we'll take C soil. Okay, and after that we will start calculating this. We know that sigma 1 is our major principal stress, is given as sigma 2 days, sigma 2 or 3 10 square 45 plus pi by 2 plus 2c 10 45 plus pi by 2. We are calculating for effective stress. That's why there will be a dash, which is the symbol of effective stress. And we know that major principal stress is equals to deviator stress plus confined or cell pressure, compressive pressure. So from here sigma 1 is equals to 250 plus 275 equals to sigma 2. Sigma 2 is sigma 2 or sigma 3 is my this 250 cell pressure, which is cell pressure. Cell pressure. Okay, see here it's a major principal stress and it's horizontally acting. This is my cell pressure or cell pressure. It is sigma 2 or sigma 3. For understanding I have wrote it down as sigma c. And after that we'll come back to this place 250, and by using calculator you can solve it directly by using an alpha method, but in GEAT examination it is not allowed. So we'll go from this method, or if you're good at maths you can solve it in just 1-2 steps. So first what we did is its total is 525, and in order to solve we'll bring this to the denominator, and after that we are left with this 10 square 45. This got cancelled out because it's a pi, so not c's will be equals to 0. So after that, in order to cancel out this square, we will take the square root in both the sides, and from here this square and this will get cancelled out, and it will remain with 1.449 equals to 1045 pi by 2. As you can see that you can simply by seeing you can understand it. I have solved it in a very precise manner, I guess. Yeah, from here you'll get the value of pi equals to 20.77 degree or 20.78 degree. Okay, round off. And after that, this is the value of pi. And in the second one, they have asked angle of the failure plane with the major principal plane. This is the sigma vertically acting is the major principal plane, and this is my minor principal plane. this is my sail pressure 203, and we know that this is my failure plane, this is my pi, and we know that it's 45 plus pi by 2, and we know the value of pi, it's 20.78. After solving this, we'll get pi c is equals to 55.39 degree. Okay, we also got the value of the angle of failure plane with respect to the major principal plane. Now we'll come to the third, normal and shear plane. Now we'll solve for this normal and shear stress on the failure plane. There are formulas, but you can solve it in this way also, either that way or this way. First, what you need to do is you need to draw the Mohr circle, this, and after that this. And from here, what you need to do is you need to draw the failure plane. After drawing the failure plane, you need to mark the pi value, which is 20.78 degree, which we have calculated here. C will be 0 because this is a pi soil. And after this, what you need to do is, this is my major principal plane, it's 525, 0, and this is my minor principal plane, 250, 0. After that, we'll mark the failure plane here. It's this is my failure plane, and this is the center of the Mohr circle, and we'll draw the angle, we'll draw the line angle from failure point to center of the circle, and is wind, and we know that this is my center of the circle. This is, we can give any name, cx equals to 0, and from the Mohr circle we know that this cx is equals to sigma p1 plus sigma p2 divided by 2, and this would be my radius. This is my radius, sigma p1 minus sigma p2 divided by 2, and we know the value, and we'll get the value of sigma cx and our radius, this. And after that, this line is my maximum shear stress on the maximum. This will be considered as the maximum shear stress on the Mohr circle. And once we have determined the value of this center of the circle and the radius, and we need to find out this normal stress and this tau shear stress. Okay, to find out that, we will from geometry or sine, you can sigma n equal to cx minus r cos theta, and to find out the value of shear stress, you can use r sine theta. By using these two formula, you will get the value of sigma normal stress and shear stress. There are some values, and after finding out, this is the thing that we need to find out. I'm tired, that's why I didn't calculate it. 378.5 minus 137.5 into cos 67.22 equals to 325.26. Unit, always remember kilonewton per meter square. Similarly, for this shear stress, 137.5 into sine 69.22 equals to 128.55 kilonewton per meter square. And in the very last, what they've asked is the normal maximum shear stress, and we know that the normal maximum shear stress will be acting in this portion only, so it will be equals to 287.5 only. So that's it. And always remember that here you will get a lot of confusion. If it's an gamma, the unit will be kilonewton per meter cube, and it is stress, it will be kilonewton per meter square, and if it's a force, it is going to be kilonewton per meter. Just remember this. And I'm considering adding for active work pressure chapter. Thank you. ये है आज का मेहनत.